Welcome to the time value of money. In this topic, we will discuss the importance of TVM in the world of finance. How does this work in terms of calculating present and future value of investments and even debt balances? This tool will also help us in valuing different kinds of securities, most especially stocks and bonds. Now, before we start, I recommend you to use or to have your calculator beside you for various calculations. What is a time value of money? Now imagine a scenario wherein you won a cash prize and you have an option to receive the 10,000 peso right now or receive the 10,000 pesos in 3 years. Now which option would you choose? For most people, taking the money in the present is just plain instinctive. So at the most basic level, time value of money is a concept that the money you have now is worth more than the identical sum in the future. Why is that? Now let's say your 1,000 pesos has the same value of the 1,000 pesos 1 year from now, right? But although the money is the same, you can do much more with the money if you have it now because of its earning capacity. In simpler terms, time value of money is a concept that says a peso today is always worth more than a peso tomorrow. Going back to our scenario or our example, by receiving the 10,000 pesos cash prize today means you are poised to increase the future value of your money by investing and gaining interest over a period of time. Now let's go to the variables of the time value of money. Okay, so in our succeeding slides, we will encounter these variables in computing the time value of money. First is the present value. For the present value, this is the current starting amount. Okay, so it is the money you have in your hand at the present time. So in other words, it is your initial investment for future. Next is the future value. So unlike the present value, your future value is the ending amount. Okay, ending amount at a point in time in the future. Now it should be worth more than the present value provided that it is earning interest and growing over time. Next is the number of periods, or we call it N or T in our succeeding slides. Now, this is the timeline for your investment or debts. Again, this is the period. It is usually measured in years, but it could be any scale of time such as quarterly, monthly, or even daily. Okay. Now, interest rate, that is I or R. Okay, this is the growth rate of your money over the lifetime of the investment. So, this is where your money earns from, okay? From the interest rate. This is a growth rate of your money. Next, or lastly, we have here the payment amount or the PMT. Now, the payment amount, these are series of equal payments or evenly spaced cash flows. So, series of cash flows or even uneven cash flows. Okay, there are instances wherein there are uneven cash flows problem that you will encounter in the succeeding slides. To have a bigger picture, let's illustrate the variables of the time value of money. We have here first the graph and the timeline. Now first in the graph, you can see that there was increase of value of the money over the period of time. So this is the period of time and this is the money that was invested in a particular security. Now here, again, this is the present value or this is the initial investment of the company or an individual. And then here, the interest rate, which is the earning capacity of the security. This is where the value of your money grows, okay? Now, the future value here, again, is the value at the end of the period. Now, again, as what I have mentioned earlier, FV is always more than the PV. Okay. Now next is we have here the timeline. Now for the timeline, again, this tick marks here, this represents the payment period of a certain investment. Now year zero, that is the present time, or that is today. Now here in year one, that is at the end of the year. Okay, at the end of the year. Year two at the end of the second year, and year three it is at the end of the third year. Now the cash here, let's say for example, we have a present value of $100. Now this $100, how much would it grow after 3 years? So what is the future value of your $100 at the end of the 3 years, given the interest rate of 5%? Now we also have types of time value of money. So here in this topic, we will be discussing and computing for the different problems for these types. So we have lump sum, ordinary annuity, annuity due, and perpetuity. Let's have the first type of TVM, which is the lump sum. Lump sum is a single payment made at a particular time. In other words, it is just a one-time payment of your investment, meaning to say there is no cash flows in between the present value and the future value. Now, if you take a look at the timeline here, you can observe that there is no cash flows in year 1 and also in year 2, which are both in between the present value and the future value. Okay, now let us examine the two different ways on solving the lump sum. We have here the present value lump sum and the future value lump sum. Now for the present value lump sum, it is the payments are made at the beginning of the timeline. It is the current value of a future sum of money or stream of cash flows given a specified rate of return, which is also known as the interest rate. Here, the future cash flows are discounted at the discount rate. Now, to solve for the present value lump sum, we have here two options. First option is PV is equal to FV multiplied by 1 plus I over M to the power of negative M times N. Or you can also use PV is equal to FV divided by 1 plus I over M to the power of M times N. Now, the two equations here will have the same result. It just look like different because of the transposing effect of the variables. Okay. Now here, FV is the future value. Okay. Future value. Then the I here is the interest rate. Interest rate. M here is the number of period within a year. And N here is the number of years. Okay. Now let's go to the future value lump sum. Now in the future value lump sum, payments are made at the end of the timeline. Okay. So this is the value of a current asset at a future date based on an assumed growth rate. Okay. Now the growth rate here again is also known the interest rate. This is used by investors to assume or estimate the value of investment in the future. Now the equation for this is FV, or the future value, is equal to PV, or the present value, multiplied by 1 plus I over M to the power of M times N. Okay, now in the next slide, we will have a various examples of the lump sum computation. Now let's have an example of a lump sum computation. Now in this example, we will be having the future value with annual rate. The problem is, Juan has 5,000 extra income from his job and wants to save for a summer trip to Boracay in the next 3 years. Now from here, next 3 years, we can already say that we are looking for the future value of the 5,000 pesos. Then how much will he have if he deposits the money in a savings account that earns 10% interest annually? Now, before we can solve the problem, we will first examine or identify the different variables that was given in the problem. Now, for here, these are the variables that was already given. So since we're looking for the future value, so here we don't know yet what is the future value of the problem. And here the present value is again the 5,000 pesos. I, or the interest here, is the 10%. N, which is the number of years, is 3. And then M is 1 because this problem is only compounded annually. Now, let's solve this using the timeline. Okay? Now, here, you can see that we have year 0, year 1, year 2, and year 3. Now, if you can observe that we only have year 3 because we are only computing the future value of 5,000 at the end of year 3. Okay, so let's take a look at the table for computing the interest or the value of investments. Now, in year 0, again, the year 0 here is a present value, which is the 5,000. The year 0 is also the beginning balance of our year 1. Now here, since at the end of year 1, there should be a growth rate of 10%. So 5,000 multiplied by 10%, the interest now is 500. Now the new value of investment now at the end of year 1 would be 5,500. In year 2, the beginning balance for year 2 is the 5,500 here. And then multiplied again by the interest or the growth rate of 10%, that is 550. So at the end of year 2, the value of investment would be now 6,050. Now in year 3, the beginning balance again is 6,050. And again, it has grown by 10%, okay? 10%. So the 10% of 6,050 is 605. So at the end of year 3, the value of the investment now is 6,655. Now here in the problem, the value or the future value of the 5,000 pesos of Juan would be now 6,655 at the end of 3 years, earning a 10% interest annually. Now let's solve this problem using the equation. Okay, so the equation again for the future value lump sum is FV is equal to PV multiplied by 1 plus I over M to the power of M times N. Now let us replace these variables into the figures or to the numbers. So FV is equal to PV, that is 5,000, multiplied by 1 plus I, or the 10% here, over 1 to the power of 1 times 3. Or you can write also here, or you can write this in this way. FV is equal to 5,000 multiplied by 1 plus 0.10 to the power of 3. Okay? And then we have here the result of 6,655. Now, it's your turn to solve this using your calculator. Now, let's have another example for the lump sum computation. Now, in this example, we will be having the present value with the annual rate. Okay, so our example here is just similar from our previous example, but with a different scenario because here one has a plan of having a summer trip 3 years from now and needs to have 6,655 for his pocket money. So from here, we can already identify that this 6,655 is the anticipated amount of Juan 3 years from now. So the question is, how much should Juan deposit in his savings account today that earns 10% annually? Now, from the question itself, we are looking for the value of today's money, okay? So we are looking again for the present value here, okay? Now, again, before solving this problem, we will first look into or identify the different variables that was given into this problem. So here is the variables. So first is the future value, that is the 6,655, and the present value, that is what we are looking for in this problem, and then the interest rate, that is 10%, n, that is 3 years, and m, that is 1. Now let's solve this first using the timeline. Okay, so just same with our previous computation, we have here year 0, 1, 2, and 3. Now, unlike the first example, we started with the year 0. Now here, we will be starting with year 3, given that we have here the 6,655 as our future value. Now, since we're looking for our present value, we will be doing the discounting rate, okay? So here, we will be using the future value factor in discounting our future cash flows into the present value. Now, to solve that, we will first in year 2, to solve for the year 2, we will discount the 6,655 with a FV factor, that is 1 plus 0.10 or 1 plus I to the power of negative n. Okay, so negative 1. So we have here 6,050. Okay, so in year 2, we have 6,050 as our value of investment. Now, let's solve for year 1. For year 1, since we already have 6,050 in year 2, we will now again discount it by 10% discount rate times negative 1. That is 5,500. So in year 1 rather, we have here the present value of 5,500. Now, to get the present value for today, which is the year 0, we need to discount the 5,500 in year 1. Okay, so in year 0, 5,500, 1 plus 0.10, negative 1. That is 5,000 pesos. So our PV here is 5,000. So this is to check our previous problem having the future value of 6,655. So here we got the 5,000 rather as our present value. Let us now solve this problem using the equation. Now, again, the equation for the present value lump sum is PV is equal to FV times 1 plus I over M to the power of negative M times N. Okay, so I will be using the first option, which is this equation. Okay, so let us replace these variables into figures or numbers. So here, PV is equal to 6,655 multiplied by 1 plus 0.10 over 1 to the power of negative 1 times 3. Okay, so again, you can also write this in PV is equal to 6,655 multiplied by 1 plus 0.10 to the power of negative 3. Okay, so using your calculator, you can get, or you should get, the total or the present value of 5,000. Now let's have another problem for the lump sum computation. Here we have the future value with compounding rate. Now, when we say compounding rate, it could be by quarter or semi-annual or monthly, okay? When we say quarterly, we are having here 4 periods in 1 year. When we say semi-annual, we have here 2 periods in 1 year. And when we say monthly, we have here 12 periods in 1 year. Now, our problem here is Juan has 5,000 extra income from his job and wants to save for a summer trip to Boracay in the next 3 years. Now, how much will he have if he deposits the money in a savings account that earns 10% interest compounded quarterly? Now, this is just the same from our previous example with the future value. Okay, so we will first examine the variables. Now this is the variable. So still we're looking for the future value here. And then our present value is the 5,000. And then our I, or the interest, is 10%. And N, which is the number of years, that is 3 years. And here our M, which is the number of period per year, that is 4, because the interest is compounded quarterly here. So here we can solve this using the equation. Okay, so we will go straight using the equation. So here again, our formula for the future value lump sum is PV multiplied by 1 plus I over m to the power of m times n. So let's replace it into numbers. So here, PV is equal to 5,000 plus 1 multiplied by 1 rather, plus 0.10 over 4 to the power of 4 times 3. So you can write here FV is equal to 5,000 1 plus 0.10 over 4 to the power of 12. That is 4 times 3 is equal to 12. So using your calculator, compute this formula. Now you should have the answer of 6,724.44. Now let's have our last example for this category of the time value of money. So we have here the present value with the compounding rate. Now our example here is just the same with our example about the present value with the annual rate. It's just that our interest here is compounded quarterly. Okay, so all variables will hold the same except for the M, or the number of periods per year. So that is 4, considering that again our interest is compounded quarterly. Now let us solve this problem using the equation directly. Now again, our formula for the present value lump sum is FV, or the future value, multiplied by 1 plus I over m to the power of negative m times n. So let's replace these variables into figures. We have here PV is equal to 6,655 multiplied by 1 plus 0.10 over 4 to the power of negative 4 times 3. So here, if you can observe, please take note that when you divide your interests, okay, when you divide your interests with m, always multiply your n with the number of periods, okay, with the same m, okay. Now compute this problem using your calculator. Okay, so you should have an answer of 4,948.36. Now again, always remember that your future value should always be higher than your PV, or your PV should always be lower than your future value. Now, if we examine here, our PV is 4,948.36, and our FV is equal to 6,655. So meaning to say 4,948 is lower than this. Now let's have the second type of the time value of money, which is the ordinary annuity. Now, an ordinary annuity is a series of equal payments made at the end of each consecutive periods over a fixed length of time. Now, here in the timeline, as you can see, there are cash flows in between the present value and the future value. Unlike with the lump sum type, wherein there are no cash flows within the present value and the future value, here there are equal payments of cash flows that are made at the end of the year, okay? At the end of the year. So, at the end of year 1, at the end of year 2, at the end of year 3, year 4, year 5, and so on and so forth. Now, here in the ordinary annuity, we also have two options of computing for the ordinary annuity. We have here the PV ordinary annuity, or the present value ordinary annuity, and the future value ordinary annuity. Now, for the formula of the present value ordinary annuity, we have here the PV is equal to the payment, that is payment, or PMT, multiplied by 1 minus 1 all over 1 plus I over M to the power of M times N, all over I over M, okay? Or you can have the simpler form, or the lesser fraction form, that is the PV is equal to PMT, or the payment, multiplied by 1 minus 1 plus I over M to the power of negative M times N, all over I over M, okay? Now, for the future value ordinary annuity, we also have the future value is equal to the payment, or PMT, multiplied by 1 plus I over M to the power of M times N minus 1 all over I over M. Okay. Now let's take an example of an ordinary annuity um, with a present value, okay? So here is our problem. Juan has the option to receive an annuity payments of 25,000 pesos annually for the next 3 years with a 6% interest rate, or take a 75,000 pesos lump sum payment. So which is the better option? Is it to receive the annuity payments or the equal cash flows of 25,000 per year for the next 3 years? Or should one take the lump sum payment of 75,000 pesos? Now, before we answer or before we solve this problem, we will first examine the different variables that was given in this problem, okay? So, here are the variables. Now, again, we are solving for the present value, okay? Since we are comparing our annuity payments to a lump sum payment that will be given today, which is the 75,000 pesos. Okay, so how much would this 25,000 for 3 years, okay, 25,000 per year for 3 years would costs compared to the 75,000 lump sum payment. Now, another variable here is the payment, which is again the 25,000, okay? And then the I here, or the interest rate, is the 6%. And then N is 3 years. And then M, or the number of period per year, is only 1, since this interest rate is annually. Okay. Now let's solve for the problem using the timeline. Okay, so since we have here 3 years, okay, so our timeline will also have 3 years for the period. Now, also, since we are looking for the present value, we will again discount the cash flows to its present value factor, okay? So we will again start from year 1. Year 1, we have a cash flow of 25,000. So to To discount the 25,000, we will divide it with the present value factor of 1 plus 0.06 to the power of 1. Okay, so you can also write this into 25,000 times 1 plus 0.06 to the negative 1. So that is just the same with what we have done in the lump sum present value. Okay, now 25,000 divided by 1 plus 0.06 to the power of 1, that is 23,584.91. So as you can see here, this figure is much lower, okay, much lower than this. Okay, so let's go to year 2. Now for year 2, still we have a 25,000. Okay, so but since it's already year 2, so the exponent here would be 2 also. So 25,000 divided by 1 plus 0.06 to the power of 2, that is 22,249.91. Okay, now let's go for year 3. Year 3, the cash flow again is also 25,000, and then our factor here, our PV factor would be for year 3. So that is 25,000 divided by 1 plus 0.06 to the power of 3, that is 20,990.48. So if add this up, add this 3-year discounted present value, we will be having a total of 66,825.30 pesos. Now let's solve this problem using the equation. Okay, so for the equation, again, our equation for the present value ordinary annuity is PV is equal to the payment multiplied by 1 minus 1 plus I over M to the power of negative M times N all over I divided by M. Okay, so here if we replace these variables in two figures, we have here the payment of 25,000 and then multiplied by 1 minus 1 plus the I of 6%, and then M is only 1 since it is only compounded annually, and then negative to the power of negative 1 multiplied by the N, that is 3, all over 0.06 over 1. Okay, so you do the calculation using your calculator. Okay, so your answer should be 66,825.30. Now, given this answer, okay, given this value of the present value, or given this figure as a present value, your answer to the question is, which is a better option? Is it having the lump sum payment of 75,000 or receiving the 25,000 pesos per year for 3 years? So the answer should be, you should accept, or one should accept, the 75,000 lump sum payment, as it is more than or greater than the value of the annuity payment of 25,000 per year for 3 years. Now let's have another example for the ordinary annuity. So we will be having the feature value. So the problem here is you plan to save 1,000 pesos per year for the next 5 years for your new car's down payment. Now, how much will you have as the down payment if you earn 10% interest rate on the savings? Now, in this problem, as you can see, we are looking, or we are estimating for the value of your 1,000 pesos that will be saved annually or per year for the next 5 years. Now, when we say next 5 years here, we are looking for the future value of your investment or your savings. Now, the question is, um, how much will you have as your savings given an interest rate of 10%? So again, before we can solve this problem, we will first look into the variables. So here are the variables. Again, for the future value, we are looking for the future value here, and then the payment, that is 1,000 per year, and then I, or the interest, that is 10%, and then the N is 5 years. Okay, for the next 5 years, and M here, or the number of period per year, is only 1 because this, or the interest, is compounded annually. Okay, now let's solve this using the equation. Now again, the equation for the future value ordinary annuity is here. Future value is equal to the payment multiplied by 1 plus I over M to the power of M times N minus 1 divided by, or all over, I divided by M. Okay, so let's replace these variables into figures. So here, the payment is 1,000 multiplied by 1 plus I, or 1 plus 0.10, or 10%, to the power of 5. Okay, so since N is 5 here, minus 1 all over 0.10. So compute that using your calculator. Okay, so you should have a result of 6,105.10. So at the end of 5 years, the value of your annual savings of 1,000 will be 6,105.10, given a growth rate of 10%. Now let's go to the third category for the time value of money, that is the annuity due. Now an annuity due is a series of equal and consecutive payments that last for a certain period, but the payment starts at the beginning of each time period. So annuity due is just the same with the ordinary annuity, but the difference is that for annuity due, the payments are made at the beginning of the year. Okay, for the ordinary annuity, payments are made at the end of the year. So for annuity due, the last payment also stops one period before the end of the specified time period. Now here in the timeline, as you can see, the first cash flow, or the first payment, was made on year 0. That is the beginning of year 1. And then last payment was made on year 4. That is the beginning of year 5. Okay, so unlike with the ordinary annuity, which is the first cash flow was made on the year 1. Okay, now for annuity due, there are also two types, or two kinds, or two ways of solving the annuity due. We have here the present value annuity due and the future value annuity due. Now for the equation, that is just similar with the ordinary annuity. The difference is that we multiplied the original equation by 1 plus I over M, okay, at the end part. Okay, so just the same with the future value, multiply 1 plus I over M on the end part. Okay, that is because payments are made in advance, or payments are made 1 year advance, or one period advance compared to the ordinary annuity, because again, payments are made at the beginning of each period. Now let's have an example for the annuity due. Okay, so for this example, we will try to solve for the future value. Now, our problem is how much can be accumulated for retirement if 2,000 pesos is deposited annually and will be made at the beginning of the year, and the account earns 9% interest compounded annually for 40 years. Now, in the problem, it was already stated that payments will be made at the beginning of the year. So basically, this problem is annuity due. Now, let us now examine the different variables that was given in this problem. So here are the variables. So again, we were looking for the future value. And the payment here is the 2,000 pesos, and I is the 9%. Okay, so N, which is the number of years, we have here 40. So N is 40 years and M is 1, considering that it is compounded annually. Now let's solve the problem using the equation. Now the equation again for the future value annuity is FV is equal to payment multiplied by 1 plus I over M to the power of M times N minus 1 all over I over M multiplied by 1 plus I over M. Okay, so let's translate this into figures. So here, FV is equal to payment of 2,000 multiplied by 1 plus 0.09, that is the interest, over 1 to the power of 1 times 40, that is the N, minus 1. All over 0.09 over 1 multiplied by 1 plus 0.09 over 1. Okay, so using your calculator, compute for the future value annuity due. Okay, so your answer should be 736,583.73. Now let's have another example for the annuity due. So we have here the present value, and the problem is consider an annuity consisting of 3 cash flows for or of 2,000 pesos annually, earning 4%. Now, what is the present value of the annuity if the first cash flow occurs today? Now, let us first examine the variables for this problem. So, these are the variables. So, again, we were looking for um, the present value here. And the payment again is 2,000 pesos, and then I is 4%, and here is again the problem says annuity consisting of 3 cash flows. So when we say 3 cash flows, meaning we are doing the annuity for 3 years. And then M is 1, considering that it is annually. Okay, so let's solve this using the equation. So again, the equation for the present value annuity is PV is equals to payment multiplied by 1 minus 1 plus I over M to the power of negative M times N all over I over M multiplied by 1 plus I over M. So to translate this into figures, we have here PV is equal to 2,000, which is the payment, multiplied by 1 minus 1 plus 0.04, that is the interests, over 1 to the power of negative 1 times 3. Okay? All over 0.04 over 1 multiplied by 1 plus 0.04 over 1. Now, using your calculator, compute for the present value annuity due for this problem. Okay, so your present value annuity due is 5,772.19. Now let's have our last type of time value of money, that is the perpetuity. Now a perpetuity, it is a perpetual annuity, meaning to say it is a series of equal infinite cash flows that occurs at the end of each period, and there is equal interval of time between the cash flows. Now when we say perpetuity, there is no endpoint of the cash flows. So as you can see here in the timeline, there is the cash flow is being projected or being represented as infinite. So here, there is no endpoint, unlike the annuity and the lump sum. We have an endpoint here, like for example year 3, that is the endpoint, but here it is infinite. Okay, meaning to say there is no endpoint for the cash flows. Okay, now since perpetuity has no And because it is infinite, we cannot compute for its future cash flows, okay, or future value. We can only compute for its present value. Okay, for the present value, the equation here is cash flows divided by the interest rates. Now let's take an example for the perpetuity. So the problem is, how much more is a perpetuity of 1,000 pesos worth than an annuity of the same amount for 20 years? Now assume a 10% interest rate and cash flows at the end of the period. Now for this, we will going to identify different variables. So the variables are the following. So PV, that is what we're looking for, and then the payment is 1,000, and then the I is 10% and is 20 years. Now, in this problem, we are going to solve for two, two kinds of time value of money. That is the perpetuity and then the annuity. What kind of annuity? The problem says that the cash flows are made at the end of the period. So meaning to say, we are looking for the ordinary annuity. Now let's solve this using the equation. Let's first solve the perpetuity. Now again, the equation for the perpetuity is PV, or the present value, is equal to the cash flows divided by the interest rate. So when we translate it into figures, we have here 1,000 divided by 0.10 or 10%. So using your calculator, compute for the perpetuity rather. Okay, so you have 10,000 pesos. Now let's solve for the annuity. Now again, what is the equation for the ordinary annuity for the present value? That is payment multiplied by 1 minus 1 plus I over m to the power of negative m times n, all over I over m. Okay, so translated into figures, that is 1,000 multiplied by 1 minus 1 plus 0.10 over 1 to the power of negative 1 times 20, all over 0.10 over 1. So calculate or solve it using your calculator. So your answer should be 8,513.56. Now going back to the question, how much more is a perpetuity? So how much is the perpetuity more than the annuity? So the answer is the perpetuity is more than 1,486.44 than the annuity payment for 20 years. How did we solve this? 10,000, that is 10,000 minus 8,513.56, that is a total of 1,486.44. Now, thank you for listening, and I hope you've learned something from this discussion. And if you have any clarifications, concerns, or questions, you may message me through Messenger or the Moodle app. And I also expect you to familiarize all the formulas, because you will be using this in our succeeding topics, which is the stock valuation and the bond valuation.